Alright. So we got our calculators, we're typing stuff in, getting a good start on it. Good job. Let me fix my attendance first. So we got Kendall here.
That's a big group. It's a big group. Oh, I thought you, what'd you call it? Like the exclamation.
Alright, how many ways can I arrange 7 books in a row? 7 factorial. So what did you write down as your answer? 5,040, right? Easy. Now be careful on this one. This is what we were talking about at the end of class yesterday. How many ways can I choose a committee of 6 from a group of 10? So there's 10 people, I'm gonna choose 6. The question you have to ask yourself is, does the order I pick the people for a committee matter? No. And since the order doesn't matter, it's a combination problem, and it will be 10C3. Kids, you cannot draw blank. How many people are in 6? 10C6. You can't draw blanks, because as soon as you start putting blanks down here, you're in order. You're first, second, third, and we don't care who gets picked first. A committee, we don't care. You just want to be part of it. We don't care if you're picked first, second, or third. That doesn't matter. Are we clear? What is 10C6? You type that in and get what?
210.
210?
Yep.
All right. How many outfits are possible if I have 10 shirts and 11 jumpers? It'd be 10 times 11, so 110. 110 outfits are possible. Please don't use factorials. I'm not arranging those clothes. I am picking one and then picking one. 10 times 11. How many ways can I award a pencil, eraser, and calculator to a group of 8 students? All right, now stop and think. How many people are there? 8. How many are going to win? 3. Does the order I pick the winners matter? Yes, because the prizes are different. I mean, if I'm doing that, don't you want to get picked in the calculator spot? Of course you do, because that's worth $100 and everything else is worth 50 cents, right? So yes, the order matters. So that one would be 8P3. If you are picking for specific jobs, president, vice president, if you are picking specific prizes, calculator, marker, eraser, then you're a P. But if you're picking a committee, or if you're giving everybody the same prize, if everybody's getting a calculator, do you care whether you're picked first, second, or third? No, you're getting the same prize. Those are C's. Okay?
336.
All right. How many ways can you arrange the letters of I love you? All right, so what do? First, we count up the letters. So how many are there? 8. So we start with 8 factorial. But then we have to pay attention to what?
Letters used
Repeated
over.
letters. Are there any?
Yeah.
Yes, there are 2 O's. Is that all?
Yep.
Yeah.
So we divide by 2 factorial. If there had been 3 O's, we would divide by 3 factorial. So I don't know what that is.
20,160.
20,160, yeah.
Yeah, I hate theory, man.
Now, when I gave this quiz, this was a bonus question, but I think you can figure this out. First of all, I am picking a committee. If you are choosing a committee, is it gonna be a P or a C? It's gonna be a C. Because in a committee, you don't have specific jobs, it's not like president, vice president, you're just picking some people. Okay, so we're gonna use C's. Now, what do I need to do? I need to pick 3 boys. How many boys do I have total? 6. And I am going to pick 3 of them. Would you agree that this is me picking 3 boys in any order, doesn't matter? Okay, now I gotta do the girls. How many girls do I have? 10. And I am choosing 2 of those. Now, for this committee, am I doing boys or girls? Or am I doing boys and girls? And when it's and, that is a times. So I'm picking 3 boys from my boy pile. I'm picking 2 girls from the girl pile. And the total is going to be girls times boys.
24.
Alright, so what's that?
God bless you.
Everybody should be typing.
Yeah, 24. 900?
I got 900. Did you get 900?
Yes.
So how many committees? That would be 900
Don't give
committees.
me all right. You get 900.
You have to label our like answers.
What?
Back?
You have to label our answers.
It's a good idea to
Put
label
these
them.
two together.
Alright, number 1. In how many ways can I arrange the letters of I miss you? Alright, so what do we do? What do we do? Count her up. 1, 2, 3, 4, 5, 6, 7, 8 again. So I'm gonna start with 8 factorial. This time, what am I dividing by? No, no, no. Each letter individually. Yes, Eli, each letter individually. Don't total up the letters. It's each repeated letter. So there are 2 S's. So I divide by 2 factorial for the S's. And then there are 2 I's. Is there anything else? No. And I tried yesterday to emphasize this. When I type that into my calculator, it's a double division. So it's 8 factorial divided by 2 factorial divided by 2 factorial. All right, no multiplication. $10,080 ways.
Okay, so what did you say first?
Right, you did that the other time. Oh, I put it down.
All right, everybody okay with that?
That's
Because you have to do this.
I'm looking at Evan's paper, and to help him, this is the way I did it. To help him remember it's a division, this is the way he did it. So he knows when he types it in, it's this divided by this divided by this. That's exactly right. All right, number 2. How many different cakes are possible if there are 6 kinds of cake and 10 kinds of icing? So you walk into the store and you're going to buy a cake mix. Okay, how many choices do you have? 6. And then you gotta buy a tub of frosting. How many choices do you have? 10. So how many different kinds of things could you have? 60. 60. That is exactly the same as jumpers and shirts. You see how it's the same thing? I walk in, I grab a jumper, I grab a shirt. I walk into the store, I grab a cake mix, and I grab an icing. So 60 cakes possible. 60 kinds of cake. How many teams of 4 can be selected from a class of 10? All right. What's the first thing that pops into your head? Is this a P or a C? Because anytime you have a group and you're picking a few, you gotta figure out, is it a P or a C? So I've got 10 and I'm choosing 4. Is it P or C? C. It's C. You just wanna be on my team. Nobody has a job on the team. It's not like you have, you're the, I don't know, you get the rake and you get the hoe and you get the shovel, we're gonna rock and work. That's not it. I just want to put our team together. So, what is, 10C4? 210? Where did it go? Wait a minute. 10C6 was 210, and now you're telling me 10C4 is also 210? That makes perfectly good sense. Can anybody tell me why that makes sense?
Are they back? Is it
It's about
Well, here's the deal, Kirsten, imagine there's 10 of you, right here, there's 10 of you. Okay, right here in the middle rows. If I grab you and you and you and you, group you together, there's my group of 4, what have I automatically done to the rest of you? Aren't you automatically grouped as 6? If you have 10 people and you choose 4, okay, so I pull you over and put you here, doesn't that automatically group the other 6? You have the chosen and the unchosen. So, when we looked at, let's look at 7C4. 7C4 would be exactly the same as 7C3. Because if you have 7 people and you pick 4, then you're unpicking the other 3. You got the picked and the unpicked in your group. Good. All right. How many ways can I arrange 6 people in a row? 6 people in a row. 6 factorial, which is 720. So 720 ways. How many ways can I choose a president and a treasurer from my class of 22? All right, so I got a group of 22, and I am picking 2 people. Is it a 22P2 or a 22C2? P. Why is it P? Because the group or the jobs are different. It's not a committee. It's not a leadership team. It's not a student council. It is a president and a treasurer. So what is 22P2? 462. So 462 ways. All right, let's look at this bonus. Now, in a couple days, I actually brought in some cards from home because I noticed some people aren't familiar with the deck of cards, but we're not going to do that today. We'll be doing probability problems later. So I deal you a 5-card hand. What's the probability to get 2 diamonds and 3 clubs? We're going to figure that out. But right now, what do you know about a deck of cards? How many clubs are in the deck? Anybody know? 52 cards are in the whole deck. You have clubs, diamonds, hearts, and spades. So 52 divided by 4 is how many of each you have? 13. There's 13 of each kind, each of suits. Okay? So I have 13 clubs in my deck, and I need to pick 3 of them. So there are 13 clubs, I'm picking 3. Is this a C or a P? C. C. I need to end up with 3 clubs. I don't care what order I get them, I just gotta end up with 3 clubs at the end. And I need 2 reds. Clubs are not red. Hearts and diamonds are red. So how many red cards are in the deck? 26. 13 diamonds, 13 hearts. And I'm picking 2. I went 3 clubs. So 3 from the club pile. This is like boys and girls. And 2 from the red pile. And order doesn't matter on that either, right? So that's a C. Now what am I gonna do with those 2 numbers? I know you can find those numbers, but what are you gonna do with them? Multiply, because it is clubs and red. And when you have an and, you are always going to multiply. If I had said 3 clubs or 2 reds, then that would be a plus. Ors are pluses, ands are times. Okay? All right, what's the answer to that one?
92,950.
What?
92,950.
92,950, does that sound right? I didn't type it in. Got that? Okay. So, tomorrow, you're gonna get a quiz, it's gonna have problems on it just like this.
Wait, what did you say?
You're gonna need your calculator, you need to know how to use your calculator, because the answer, like this, is gonna be the answer. This is what I'm gonna look at for your work to give you partial credit, but that's what's gotta be in the answer blank.
Since it's a word problem, do we have to put like ways and
It's a good idea to do that. I probably am not gonna count along if you don't, but it's just a good habit to get into it. All right, everybody clear on that? Okay, let's get our notes back out. And we're gonna do some binomial
The hole puncher.
expansion.
Garrett, can you give me that hole puncher, please? That's mine. Here. Can you give me that one? Alright.
Okay, so for a moment, I don't want you writing anything down, I just want you watching for a moment, because I want you to get an idea of what we mean by binomial expansion. What am I even talking about? Section 9.2 is about binomial expansion. It's going to tie into probability 9.3. So let's look at it. It looks very different than what we've been talking about. But what is it? What are we talking about? Well, if we had a binomial, and a binomial by 2 terms, like x plus y. If we, don't write this down, if we raised it to the first power, it would be x plus y. Okay. What if we raised it to the second power though? Remember, you don't just distribute the 2. That would be a FOIL, right? And I know, because I've done this like thousands of times, that that's going to be this when I FOIL it out. Again, don't write this down. Don't write this down. There's a point to what I'm doing. All right, and then we got, what if we had x plus y cubed? We are expanding the binomial. We are multiplying it out. So this would mean x plus y, x plus y, x plus y. And that would just be a whole bunch of FOILing, right? And again, I know that would be x cubed plus 3x squared y plus 3xy squared plus y cubed. Alright? Now, the next problem, the first problem in our notes says, okay, what is x plus y to the fourth? Well, believe it or not, I could just write that down, just like I've done here, because there's a trick to it. And that's what we're gonna learn today, is the trick. How do we do x plus y to the fourth without memorizing it, that would be awful, and without actually foiling it 4 times, because that takes forever. So what I want you to do is kind of take a guess right now. What do you think, just based on what I've done so far? I did the first power, second power, and third power. What do you think the fourth power might look like?
4 x to the fourth plus 4x to the third y plus 4x to the second y to the second plus 4x plus y to the third, or y to the third, yeah. And then plus y to the fourth.
Now, he has made an absolutely great guess. It's not quite right, but it's really, really close. So, do you see what Derek saw? He said, it looks like I'm gonna start with x to the fourth. Does that make sense to you? And it looks like I'm gonna end with y to the fourth. Does that make sense? And then he said, if I look at my exponents here, let's look at this one. This was x cubed, and then in the next term, it went to x squared. And in the next term, it went to x, plain x to the first, and then there was no x. So he said, I'm gonna do the same thing. He's got x to the fourth, x to the third, x squared, x, and no x. And then his y's work the same way, but from the other end. So y to the fourth, y cubed, y squared, plain y, no y. That is absolutely amazing. Do y'all see that? Now, he said, I think this number here should be a 4. And he based that on the fact that when we started with x squared, we had plus 2, and then x cubed was plus 3. So he's thinking x to the fourth is going to be plus 4. That seems logical to me. And the same thing down here. He said, it looks like that guy's going to be a 4. The only number that's not right, Derek, is that one right there. Otherwise, you did perfect. You did absolutely perfectly. This number is actually a 6. Now, where in the world did that 6 come from? First of all, if you aren't listening to me, don't want to listen to me, don't want to learn what I'm talking about, you can do this problem by foiling x plus y, x plus y, x plus y, x plus y. It will take a long time, but you can do that. And if you did, this is exactly what you would come out with as your answer. So the question now is, how do we know that that's a 6? Without multiplying it all out, how do we know? The secret is in something called Pascal's triangle. Sometimes also referred to as the arithmetic triangle. Blaise Pascal was a brilliant mathematician, and he didn't actually originally develop the triangle for this purpose. He used it with probabilities. He was really smart. His friends knew he was really smart, and they said, hey, help us win. You're so smart. Help us figure out how to win. So that's where game theory and all that started, and it started with a coin toss. Binomial, x, y, head, tail. And this is what he discovered. If you, well, never mind. I'm just gonna write down the coefficients so far. I know I have 1 and 1, I have 1, 2 and 1, I have 1, 3, 3 and 1, and now I'm telling you this next row is this. And I can tell you what the next row is, because it always starts and ends with a 1, just like Garrett said, 1x squared, or 1y to the fourth, 1x to the fourth. And then the numbers in the middle of the triangle come from adding the 2 above. So the next one here would be 5, the next one here is 10, 10, 5. So how did I get that 6? I added the 3 and the 3. Now, these numbers are the coefficients. So if we needed to do x plus y to the 5th, I know my coefficients are 1, 5, 10, 10, 5, 1, straight from the triangle. Now, what did Garrett discover about the letters, about the variables? Well, if I'm going to the 5th power, this will be 1x to the 5th. This will be x to the 4th, 3rd, squared, x, and then no x on the end. And then what about the y's? Well, I can either build up from this end or build down from that end, it doesn't matter. So this would be y to the 5th, y to the 4th, 3rd, squared, plain y, and no y. And there, my friends, is the answer to x plus y to the 5th. You just FOILed that out in about 30 seconds, I don't know, didn't take very long to do that. Okay? Now, let's take a look at example B. Because it has some other things in it other than x's and y's. You need to be able to build Pascal's triangle. So let's make sure everybody follows. So I started with a 1 and 1. And then each row begins with a 1 and ends with a 1. And then all of the numbers in the middle are found by adding the 2 above. Okay, everybody good with that? See how that works? So that's how you build the triangle. So just for fun, let's build the next row. What would the next row be? What goes here? 6. And here would go 15, 20, 15, and 20. Yeah.
It's 6. This one. It's 6.
Thank you. All right. Someday you'll be old and your brain will fire right here. All right, x plus 2y to the 3rd. This one is a little different because of that 2, so I'm going to show you how to handle the 2. We're going to start by looking at the 3rd row of our triangle. So when it's something to the 3rd, we're going to look at the 3rd row. All right, so the 3rd row is 1, 3, 3, 1. Leave yourself some space. It's called expansion. Now, in the examples I just erased, every problem just had an X and a Y. This one has an X, so I'm giving every term an X, but it has a 2Y. So before, every term had an X and Y, now it's got an X and a 2y. So I wrote down my 3rd row of Pascal's triangle, this row right here. I wrote that down. Then to each of those numbers, I attached an x and a 2y. Now tell me about the exponents. I need to put the exponents on. What will be the exponent on x right here? 3. And then remember, they count down until you don't have any more. Right? So this is going to disappear because I don't have any x's there. Right, and what about the y's? What happens to the y's? Same thing from the other end. So 4, not 4, 3, 2, 1, 0. Because here there are no y's, right, in that first term. So let's put pluses between each term to kind of keep it separated. It really helps if you give yourself room to work. So what is my first term? What does this just end up equaling? X cubed. Perfect. Now be careful here. What's that one gonna end up equaling? No. It's 3 times 2. So that's gonna be 6 x squared y. These are all multiplied. So you have a 3 times an x squared times a 2y. So that ends up being 6x squared y. Now be careful. What about the next one? That's going to be a 3, an x, and a what? Here's where we make our mistakes. What is that? 4y squared. The whole thing is getting squared. So it's 4y squared. Which means that all becomes 12x y squared. And how about our last term? What does that end up being? Be careful, it's not 2y cubed. It's actually 8y cubed. Why is it 8y cubed? Because 2 cubed is 8. So when you put numbers in your binomial like that 2, you have to power it along with the letters that give it the exponent. Curious, your hand up? Just stretching? Good. Miles, you want to wake up, Bo?
What?
Get your head up. All right, here we go. Next. This one is going to be big, so I'm going to have to erase my triangle. Before I erase it, does anybody have a question about the triangle? We're going to use that in this next problem. I just need space. Okay. So the problem says, find 2x minus y to the fifth. All right, let's start with our triangle. Which row of the triangle will I need? Fifth. And I just erased it, maybe you have it written down. 1, 5, 10, 10, 5, 1. There's my fifth row of my triangle. Start with that. Now, this time, the two pieces of the problem are 2x. So I'm going to put a 2x next to every one of these numbers. Make sure your 2x is in parentheses. So 2x, that's the first part of the problem. And what's the second part of the problem? A negative y. Put it in parentheses. last example, we had an x and a 2y. This time we have a 2x and a negative y. Everybody okay? Now I need my exponents. So right here on the first x, what will be the power? 5. And then I will count down all the way to the end where it is a 0 because there is no x in the last term. Remember that from our previous work? And then, what about the negative y? They'll be the same thing, either start at 0 and build up, or I usually, since I'm down here, start down here and work my way down. Now, one thing I didn't mention, well, wait first. By the time I get down here, there's no y. Right? Now, one thing I didn't mention before, maybe you observed it, is if you look at each term, look at your exponents. You have a 4 and a 1, a 3 and a 2, a 2 and a 3, a 1, 4. The exponents should always add up to the problem. Okay? So if they don't, if you had, a 3 and a 3 here, it'd be wrong. They have to add up to whatever that is. Alright, let's put plus signs in between all these. And let's start simplifying. Look at your first term. What is it? Do not say 2x to the 5th. You will be wrong. 32 x to the 5th. Why is it 32? Because the whole thing, 2x, gets to the 5th. And 2 to the 5th is 32. This is a multiplication problem. So what am I multiplying? I'm multiplying a 5. What's this? 16x to the 4th. And a negative 1y. That's a negative 1y. I'm multiplying. 5 times 16 times negative 1. Negative 80. And I still have x to the 4th, and I still have y. So my second term is negative 80 x to the 4th y. Would you work on this one? See if you can come up with that term. Remember, it's multiply, multiply, multiply. There's no add and subtract in there. This is all multiplication. See if you can figure out what that term would be. Anybody want to hazard a guess? What do you think? What? Okay, so I've got a negative 80 x to the 3rd, y to the 2nd. I totally love that except for one thing. There's one thing. 80 is the correct number. Obviously, it's x cubed y squared. That's beautiful. But what? What's wrong with it? Does anybody see? What is negative 1 squared? 1, positive 1. So that should be a plus. Because this is 10 times 8x cubed times positive y squared. So that term's going to be a plus. When you square a negative, everybody okay with that? Square a negative, it becomes positive. Right? Okay. Now what's going to happen here? x squared. Now, this is a negative 1 cubed. What happens when you cube a negative? It stays negative. So this is going to stay negative 1y cubed. It's not going to become positive. It's going to be negative. So when I multiply, I'm going to get negative 40, 10 times 4 times negative 1, times x squared, y cubed. All right, finish it. You got 2 more. I need this one and this one to finish these. Figure out what those are. Tell me what you get. Julius, you got it?
No, I was gonna ask you a question about how, I think I answered it myself though, is how come like the y over here with the negative 40 is like, is to be negative 1 y squared, but the other one is positive y squared?
No, they all have a negative 1. They all have a negative 1. It depends if you raise it to an even power, it becomes positive. A negative times a negative is positive. But if you're raising it to an odd power, it stays negative, right? All right, who got this one? Anybody got this one? This one's gonna be positive 10x y to the 4th. And this one's gonna be negative y to the 5th. Let's turn the page then, we'll go to number 2. What we have done with all of this is we have literally built the entire expansion. We wrote out every single part of this problem. Obviously, we have a first term, a second term, third term, fourth term, fifth term, sixth term. We wrote them all. In the next exercise, it's not asking you to write them all. It says, find the 5th one. Find the 5th one. Does anything about problem 2A bother you? What? What row of the triangle will I need? The 11th. Does that bother you?
No.
It should, because building out, could you build to the 11th row?
Yes.
Absolutely. But that is going to take, the numbers are going to get big. It's going to take some time, and it's going to be absolutely humongous. All right? I don't want to do that. I don't think you want to do that. Could we? Yes. But math is all about being efficient. So let's look at something. I need, all right, I need each row here, each column, what do you call this? All right, so I've got Evans, well, you're kind of scooch over, so I got Ty's group over here. I want you to get your calculator out, and I want you to type 5C5. I want you to figure out what that is. Cam, I want you guys to do 5C4. Charles, you guys are doing 5C3. Just type that in for me. Eli, you're doing 5C2. Luke, you're doing 5C1, and Abby, you guys are doing 5C0. All right, just type in one thing, tell me what the answer is. I want you to look at these numbers. So, what did you guys get? You got 1. What did you guys get? Cam?
Kim wins.
Keep typing it.
Luke? 5? 5C0. 5C0 is 1. All I asked you to do is type it in. You didn't have to do anything with it, just type it in. Do those numbers look at all familiar to you? Look at your
Yep.
notes.
It's like the fifth.
That is the fifth row of Pascal's triangle. Your combination numbers will produce whatever row you want. So if I need the 11th row of the triangle, then the first number in the 11th row will be 11C11. The second number will be 11C10,
That's a one.
and I just count down. Now, the good news is, I don't need to count all the way down. I want the fifth term. Here's the first term, second, third, fourth, fifth. There is your number that you need. If you built the whole row, you built Pascal's triangle, you would get these numbers, just like we got the fifth row up here. This is the 11th row. We want, in this problem, the fifth term. So the first thing I'm gonna do is get my coefficient. This is a number. What is 11C7?
330. 330.
330. Now, I know that next to the 330 is going to be a 2x and a y. Because that's how it works. You write down your numbers, and then next to each number, you write down the two parts of the problem, which are 2x and y. And then what do we do? Put on your exponents?
Yep.
So let's think about that for a second. How do we put on the exponents? We start with the first term, and whatever the power is, that's what we put on the x, right? So this would be x to the 11th. This would be x to the 10, 9, 8. Isn't this going to be x to the 7th? Just counting. And then, remember what I told you, if this is to the 11th, then these guys have to add up to 11, which means that has to be 4. Put your hand up, Eli. Okay, so now we simplify. So we've got a 330. Now what's 2x to the 7th? What's 2 to the 7th? 1, so 128. And y to the 4. So these are the three things I'm multiplying. You're always going to be multiplying three things. I'm multiplying 330, 128, x to the 7th, and y to the 4. So 330 times 128, 42,240, x to the 7th, y to the 4th. All right, one more, and I'll shut up. Here we go. We're getting x minus y to the 10. Now, before we start, does everybody understand that when I start multiplying this out, my first term is going to have an x to the 10. My second term is going to have an x to the 9, right? And then x to the, is everybody clear on that? This is what's going to happen when I start multiplying it out. And it's eventually going to get all the way down to x to the 0, or no x at all. Right? My job is to find the coefficient, so this is called the coefficient, for the term that would end up with an x to the 4th, x to the 6th. doing problem B. Now, all I have to do, oh, that's a Y, sorry. This is what Y this is. All I have to do is figure out what this number is right here. Alright, so here I go. I know that this is the term I want. I know right here, the number would be 10C10. What would it be right here? 10C9? 10C8? What is going to be the coefficient right here? 10C4. What is 10C4? 210? So your coefficient is 210. So, quick recap. Where do your coefficients, that is, where do these numbers come from? If they're small enough, they can come from the triangle. You have it written on your papers, you can use the triangle. If they're bigger, you can use your combination, your C button. And you always start with your power and then go down. 11, 10, that, and so on, all the way down. Okay?
Talking about pictures.
So, I'm gonna assign 7.2 or 9.2 tomorrow, which will make it due on Monday upon our return. So you can do it right now. So if you've got a head start on that 9.2,
I got it.
go ahead. We have one more problem to
What are you
do.
gonna do on the
I don't know.
Yeah, they need to teach math.